We're now going to go ahead and present an object-oriented design for our expression tree processing app. To do this, we're going to create the design that's based on modeling classes and objects in the domain of expression trees. In order to do that, we're going to apply scope, commonality, and variability analysis to determine the stable application programming interfaces, or APIs, as well as the variable extension points. We're going to start by modeling the tree as a collection of nodes. And in keeping with our idea of trying to model the domain, those nodes will be divided up into different kinds of nodes: binary nodes, unary nodes, leaf nodes, and so on. And then we're going to find a way to be able to represent those nodes using a hierarchy of classes that capture the different properties of each type of node. For example, we're going to have certain kinds of classes that deal with the properties of a unary node, which has one child. We're also going to have classes that deal with properties of binary nodes that have two children, things like multiplication or division. And of course, we'll also have types of nodes that deal with classes that have the leaf nodes, the things that are the numbers, the leaves of the expression tree. Once we've done this modeling, we're then going to apply gang of 4 patterns in order to guide the development of a framework of extensible classes. Let's take just a moment to talk about what a framework is. A framework is an integrated set of classes that collaborate to provide a reusable architecture for a family of related applications. Let's break that down a little bit. Frameworks turn out to have 3 distinguishing characteristics that differentiate them from other forms of software systematic reuse, things like class libraries and so on. The first of these characteristics is their support for so-called inversion of control, which is also sometimes humorously referred to as the Hollywood principle, where you don't call something directly, you register with it, and it calls back to you. The framework calls you back when something interesting happens. So typically in a framework, it owns the event loop. It owns the flow of control for the most part. Another characteristic of frameworks are that they tend to embody domain-specific structure and functionality, which is realized in the form of abstract classes with virtual methods that you inherit and customize in various ways. There are various ways to think about the kinds of domain-specific properties that we find in frameworks. One type of framework would be called an application framework. These would deal with things in application domains like electronic stock trading, social media, mobile applications, avionics, mission computing, automotive, anti-lock braking, and so on. There are other types of domains, however, that are more infrastructure-oriented, things like networking, databases, graphical user interfaces, and so on. Both of these classes of frameworks are examples of things that have systematic reuse. They just differ in terms of what level of generality and specificity they tend to emphasize. The last characteristic that is used to define a framework is that they provide so-called semi-complete applications, where the framework provides the bulk of the canonical control flow, the common structures, the recurring roles and responsibilities in a particular domain at a certain level of abstraction. And then you come along as an application developer or an infrastructure developer, and you customize certain predefined hook methods that the framework leaves for you, where you can go ahead and provide application or domain-specific functionality to specialize the particular abstractions for whatever it is you're trying to do, for your business needs, for your business logic, and so on. And when you combine these 3 properties together, you get great support for systematic reuse. It's also worth noting, of course, that frameworks embody many of the patterns that we've been talking about, many gang of 4 patterns, many other patterns from the patterns literature as well. So there's a tremendous synergy between patterns and frameworks. Something else we're going to do when we do the object-oriented design of our expression tree processing app is we're going to integrate pattern-oriented language and library features with frameworks. For some of the things we're going to be dealing with, they'll be very application-specific frameworks. In our case, a framework for dealing with expression tree processing. And as you'll see as we go through the various examples in Lesson 5, there's a lot of patterns that come together to provide a very highly dense pattern-oriented design space. For example, we'll see the use of iterator in conjunction with strategy and visitor and factory method and bridge. All these things come together in various parts of the code to give us a very powerful framework for building extensible processing for our expression tree processing app. We're also, of course, going to be applying some off-the-shelf frameworks. In this particular case, the off-the-shelf frameworks will come from Android, which is a collection of frameworks and virtual machines and other levels of middleware and operating systems and device drivers and so on that provide a nice environment, a common software infrastructure for the domain of mobile applications. things like smartphones and tablets and so on. And we'll be looking at various ways you can take pieces of Android and use them in order to provide the container to execute some of the different operating modes of our expression tree processing app when we're using graphical user interfaces.